Login accepted.
Hello, and welcome to How to Query a Stream. My name is Tim, and what I do is I run the developer relations team at Confluent. Again, this is my third week on the job. I just went back there. I had been there some years ago, and I'm back. I just couldn't stay away from the broader streaming world. And it's an exciting time to be alive in a lot of ways, which we'll kind of talk about today. Now, the visuals for this talk, just a quick note. I went a little crazy with Gen AI because aren't we all these days? But all of these pictures are based on the style of an Italian Renaissance artist named Caravaggio. And if you know your art history a little bit, he was one of those guys who was a big deal. There was kind of a before and after in the Italian Renaissance, and if you came after, you sort of had to deal with Caravaggio. You know, I'd like to be that kind of person in what I do. Although not the kind of person who got in sword fights every night and was often on the run from his enemies trying to track him down, from people that he stabbed with a sword. A very, very mixed figure. Anyway, that's sort of the visual theme for today. Some background about where we are. And I've been telling this story pretty much any time I give any talk because it's gotten into my head. I can't get it out. I think it's really important. I think it's important context for us. There was, until recently, a simple time in our lives. When you needed to write an application, you had a database, and that database held a snapshot of everything that was true in the world. Then you wrote a program that made changes to that database, exposed some kind of user interface, and changed the state of the world in the database. And sometimes representing the state of the world is hard. Sometimes encoding business rules is hard, and coming up with clever user interfaces is hard. It's not like it was easy, but we knew how to do it. There was a tool set that we had, and most of us in this room have some experience with building applications that way. It felt like everything made sense. Now, to get some insights into what has happened, remember that database was just a snapshot of what was true in the world. It's changing all the time. To try to get insights into what was going on in the business, we would extract changes from that database approximately daily, squish them around into some other form, and go put them in some other database that you could run reports against. This was the classical data warehouse in its various forms. And it wasn't just databases. You could draw in stuff from all over the place. You could optimize the schema, pre-compute things. It was a wonderful world to have access to all of this data. What happened? Well, the internet happened. And it's curious to me, as I look back on the history of these things, I see there were mainframes from approximately the 50s, and there still are mainframes. And then in the 80s, before most of our times, I was a teenager, I wasn't like a working programmer. The 80s, there was this disruptive new paradigm called client-server, where you wrote software that ran on a PC and it stored its data on some server in a closet, right? That was a really big deal, and that was kind of the first major architectural table flipping that had happened in the history of computing that upset the mainframe paradigm. The internet came along just a few years later, and the internet transformed the world in so many ways, but the way early websites were built were with that same tool set from the 80s. They were client-server architectures. All of the people who had just kind of pioneered this client-server thing 10 years ago, the web came along, they're like, okay, let's build websites that way now. And it worked fine until, about 15 years in of the history of the web. You get to kind of 2008, 2010. What do you have? You have mobile devices now. So instead of using the internet means you go home and get online, now you have a computer in your pocket that's connected to the internet all the time. And suddenly, over the course of some time, so much of our lives are mediated through devices, mediated electronically, social lives, commercial lives. And that started to put some pressure on this nice old monolith world that we had and the nice old data warehousing world that we had. Those things just stopped working real well. And so some new ideas entered the scene. We had the whole big data thing in about 2010. Hadoop entered the chat. Hadoop didn't really last long as a going concern, but it gave birth to a bunch of other things. And these days we just, you kind of say data lake. That's the era of Hadoop. In the analytics world. In the application architecture world, we couldn't build monoliths anymore. Those weren't really working. And so we started breaking those into pieces and calling them microservices. And we experimented with various schemes for reconnecting these microservices to each other, right? The programs to each other. Didn't work very well at first, but we finally landed on Kafka, around 2015, 16, 17. That's becoming a really important thing. And people are discovering, okay, we had to break our programs into pieces. That was a good idea for reasons I'm just going to let us assume together for now. And connecting those things, I wish I could make all of my Kafka diagrams look like this. It's just a good look, right? Here are these things, these like reactor vats connected by pipes. It's a good image. And that really started working. So now we're in a place where microservices feel like they work. This is as big a change in software architecture as client-server was in the 80s. And it's fascinating to me that it took a good 15 years of consumer internet before the architectural paradigms that were in place at the beginning of the internet really started to break. But they broke. This is the world we live in, and we're getting it figured out. Kafka also gave us the notion of processing data in real time. We still had data lakes. We still have data lakes. But you didn't necessarily have to wait until the next day until data was copied to do some processing. You might be able to do that right away. And that notion of right away, again, is sort of just getting infused in unspoken expectations of how software is supposed to work and the way we as consumers, not even as developers, are interacting with mobile devices. Stuff just happens immediately. We should sort of expect that, right? And that's becoming baked in. So Kafka is increasingly ruling everything around us, and now, rather than the center of our world being a database where we make changes to the state and everything grows up around that, we have this emerging paradigm where logs are the fundamental abstraction. And they are better than databases for connecting all these services that we write. It's a win. That seems like that conclusion is becoming fairly well established. They're easier to extend. They're easier to reason about. They're very hard to query. So, all of that history to say, here we are, we're in this increasingly Kafka-centric world where Kafka doesn't answer everything, but it is functioning as this data substrate that we build systems on top of. And it's a very good thing, but it's hard to ask questions about what's been going on. Because you can't ask the only question you can ask a log is, what is the next event you have for me? There is no query semantics that they expose. And that is what this talk is all about. We are still struggling, I think, as a global community of people who build systems of this kind, to figure out the correct intersection of streaming system and database. Everybody is playing around with that. I'm going to go through a bunch of different approaches, a bunch of different products and some different startups and different ideas people have for solving this problem. And I don't want it to seem like there's a correct answer for much of anything. We are surveying the landscape and looking at the trade-offs because we're in this point in our history where we are exploring some undefined territory. And so you see a bunch of crazy things being tried. Now, nerdy teenage Tim, who was reading Byte magazine and reading these think pieces about client server and how it was going to end sickness and there'd be no more sadness or crying or pain or anything because of client server. Seriously, it was like breathless tones. People were writing about that in the 80s. I as that teenage boy was reading about client server then, and there was then this flowering of all kinds of weird database ideas and different ways of being a database that are historical artifacts now. They're footnotes if you study that part of computing history from those few years. And now, fast forward to now, we have that same thing going on. So that's what this survey is all about. We are experimenting with ideas. I want us to be aware of that experimentation, thinking about the trade-offs, and trying to figure out where to go. So in this intersection of streaming and database, we are still going to see the broad categories of OLTP and OLAP emerge. Okay, there is still kind of a transactional way of thinking about things and an analytical way of thinking about things. Transactional is kind of what's the state of this thing right now. Analytical is broadly what's something that's true about all these things. Let me get some insight into what's happening versus what's my current balance, what address do I have configured in my account, those kinds. So there's a transactional sense and an analytic sense. I will use those terms throughout the talk as we look at the systems, the different solutions that we're going to cover. Let's look at our options. So how do you query a stream? Kind of these things. All right, you could use Kafka Connect and a relational database. You could use Kafka Streams if you're into that kind of thing. There are several streaming SQL options in the world of different kinds. There's the good old cloud data warehouse, the Snowflakes, the Redshifts, to some degree Databricks. There's the now, it's funny, we can say traditional data lake now. It's kind of a 15-year-old idea at this point. And I think distinct from the cloud data warehouse. We'll look at those as separate solutions. And there is this new emerging category of the real-time analytics database that is not a cloud data warehouse, not a data lake, not precisely a streaming SQL. It really is this other thing that's interesting in its own right. So this is what we're going to go over. And, play my cards right. We'll even have some time for Q&A. That's optimistic. I never plan adequately for that, but it's okay. We can talk after. Okay. That is, I think, obviously a representation of Kafka Connect. Those are little Connect workers busily copying from the giant scroll into tables. So that's if Caravaggio had to represent Kafka Connect, that's what it would look like. Now, if you don't know Kafka Connect, it is a part of Apache Kafka, but it is this separate little distributed system, this separate cluster you run off to the side. So you got your Kafka cluster, and then you have your Kafka Connect cluster. And in the case that we're talking about here, this is going to be a sync connector. So Connect is going to read from Kafka. It's going to function as a Kafka consumer and then write to some external database. And if you've got that Connect infrastructure set up, or you're using a fully managed Kafka that has Connect as a little checkbox, the infrastructure is there, and this just becomes a matter of configuration. You declaratively set up the connection you'd like, and then you get this table representation of the stuff that's in your topic. Generally, doing this to a relational database is probably something you're going to do if you've got smaller data, all right? And this is also more on the transactional side of things. Let me tell you exactly what I mean there. If you've got a topic, there's kind of broadly two kinds of things you can put into Kafka. You could put pure events, like clicks or sensor readings or things like that, things that happen. Or you could put basically change logs, like updates to entities, where the key of the message is some unique identifier of the entity, and then you've got just a serialized snapshot of that entity, like my account. For reasons, I've moved several times in the last few years. I've had more changes of address in the last 3 years. Not a fan. But, so I'm making changes. I've got this little list now, because I got at least one more move planned in the next kind of year and a half, of all the places I have to go update on the internet. And a topic could have my account, including my current address. And so that kind of thing, where the key is my account number, UUID, whatever, and then, well, my user account data is in the topic, that would get then Kafka connected into a relational database, and you're going to look that up by a key, pretty much. So when I say transactional, that's what I mean. I want the state of this entity out in the world, and I'm interested in looking up that one thing. So if it's relatively smaller data, the kind of thing I could put in, say, a Postgres, then this is great. This is honestly a fantastic solution. It is not in any way a bad thing. It's got some trade-offs. It's got some places it might not do too well. And it's familiar tools. It's not exactly hard to go find help on Kafka Connect and tutorials and examples. And if you can't stand up a relational database, you can find help doing that too. That's just not hard. So the nice thing about this, maybe the best thing about this, is it's so familiar. When I query the database, I know how to do that. If I want an index other than just this kind of key value store primary key thing, if there's some other field I can index, I can do that. So this is fine. We kind of start with something very simple, very easy. The trade-off is if you're not running Connect, now you have to run Connect, and that's kind of seems like a lot just to do this, but a lot of people have Connect in their Kafka infrastructure, so no problem there. Okay, you've got a stream and you are using Java or some nearby JVM language like Kotlin or something, and you want to learn Kafka Streams. This is plenty of people who go deep with Kafka end up in Kafka Streams at some point, so it's hardly a bad place to be. Kafka Streams is going to serve us on the transactional side and on the analytical side. So let me take transactional first. This is kind of nice. So it is a Java API, and I can use it with like a one-liner, some little boilerplate setup stuff, but then a one-liner API call to ingest from a topic and make an object within the Kafka Streams API called a K-table. And a K-table is kind of what it sounds like. It's a queryable table version of the stream. So if I've got that thing where I've got the user ID is my key and my account serialized representation is the value, whoop, I just take that in, and now I've basically got an in-memory hash table version of that I can query. That itself, creating that table, one-liner, very easy in code, and it again is a key value store, so I am querying just by that key, not by other things. If I want to query by other things, I have to write a little bit more code to repartition. It'll be 2 lines now. I'll repartition that topic and create a different K-table, but it's fairly simple to do. If this doesn't fit in memory on one instance of my application, it's okay. I can scale that across a consumer group. It's got all the scalability properties that consumer groups have. It's pretty cool, and I can read that through a Kafka Streams API called interactive queries. So it all works. Now, in terms of actually doing this, I'll show you. This is the code, and it's not intended to be big enough to be readable. It's intended to be, hey, look at that. That's 2 lines because I put a line break after the equals. There's just not much to it, right? The code to read this with the interactive queries API is, in my opinion, harder than it should be. That's really just a complaint. It absolutely works. You can get the whole job done with this. It feels like interactive queries. You just got to jump through more hoops than you ought to need to. But using Kafka Streams transactionally to query a stream is a first-class option. And it's going to tend to be the option that you reach for if you're already using Kafka Streams for other things. It's going to seem very natural to do this. And honestly, there's no but after that. If you're already using Kafka Streams and you need to go do a key lookup on a thing, just pick it up and do it. Now, Kafka Streams on the analytical side of things. This is not, I want the current state of an entity. This is, things are happening and I want to make sense of them. But I want to make sense of them in a queryable way. So I'm still going to end up creating a table that I can query. So, Kafka Streams, in addition to this cute little way of making a stream into a table, is a full-featured stream processing API, filtering, joining, all kinds of cool stuff with time windows, grouping in various ways, arbitrary reducing functions, all kinds of things in this nice Fluent API. There's also an option to jump down underneath that Fluent, pleasant, top-level, easy-to-use API and process data on a message-by-message basis. Kafka Streams will give you access to its state store and each message, and you can just sort of do whatever arbitrary stream processing you want. Kafka Streams can ingest a stream, do all this stateful, interesting stuff, and output a stream. That's actually not unusual at all. It's just not this talk precisely, right? We're talking about how to query a stream, not how to do compute over streams. So that's a somewhat typical way to use Kafka Streams, but here we'd want to do this streaming computation and then end up with a k-table that's queryable by some key. And whatever that is, I don't know. It's a fair bet that we grouped by some field and ran some reducing function over the events in the group over some sliding time window or something like that. And so whatever key we grouped by is going to be the key we query the k-table by. So this is a way of querying a stream. Important to note that every, I say read pattern on the slide, that's like every query that you want to do, you are hand coding that as its own Kafka Streams topology. A Kafka Streams program or stream processing job is called a topology. There's going to be a class where you have a method that interacts with the API. That topology is going to live there. So you are kind of hand coding these queries. Again, if it's a part of your toolkit, it's going to feel very natural. If, on the other hand, you knew nothing about Kafka Streams and you're like, hey, Tim, I'm new to this querying world, I want to do some analytics on my stream, and I say, oh, it's great, you just have to write a bunch of Java code for each thing, and you say, I miss SQL. Is there anyone who will let me do that? You know, that would be a fair reaction. So again, when Kafka Streams is a part of your toolkit, you're just not going to mind. If it's not, this is going to feel like somebody's slapping you around a little bit, and it should have been easier. Of course, querying the k-table that you set up, you're going to use this interactive queries API. Some more sample code. This is a word count. That's the thing about life in the last 15 years as a software developer. There are all of these words to count. It seems like every day I'm saying, I just have this file with all these words, and I need to count them. Is that you too? No, it's not me. I don't know how that example has become so enshrined, but I'm a part of the problem. I have word count on my slide. At least it's apples to apples, right? If we all talk about word count as our hello world, then you can get a sense of what things look like. Anyway, let us move on, because I just said if you were doing analytics with Kafka Streams, and that was all you had, and you hadn't learned Kafka Streams already, that would seem like a problem. So let's look at the streaming sequels. There are a lot of these. And before we get to the list, I need to say now, if they all sound very similar, you're onto something. At this level of introduction, they really, really do. Now, you can go deeper on them, and there's a book coming out called Streaming Databases by my friends Ralph de Buisman and Hubert Dulay that has chapters on these things that do get into some deeper differentiators that just take more time. Excuse me. So these are all fairly similar to one another, but I'll go over what the options are as of right now as I see them. We've got a service product startup named Materialize, one called Delta Stream, one called Rising Wave. Confluent still has KSQL DB that is available in our cloud product and still a supported thing. And we'll explore whether Flink SQL belongs in this list or how it would fit. This this talk without talking about Flink, there'd be a problem. But there's a question mark on Flink SQL, and we'll see why. All right, materialize. Materialize represents itself as a replacement data warehouse. It's really saying, if your data sources are Kafka topics or the equivalent, why dump those into a data warehouse and use batch query tools, right? Why not just do all of this in real time? So it's wanting to be this streaming data warehouse, and it's sort of by default streaming data warehouse, integrates with the usual suspects, and not surprisingly, its central abstraction is a thing they call the materialized view. So that is, again, a different way of making a Kafka topic into a table. So you've got structured data inside that Kafka topic. It's Avro, protobuf, it's a JSON document. It's a thing that's got fields. And so you can take those messages and turn them into this materialized view. Maybe with some computation first. Okay, it's not just the raw, I'm going to make a K table out of this. Materialize will let you define in SQL computation before you make that table, but everything is going to revolve around this queryable materialized view. And they are not ephemeral things. They are persistent stores of data that are the computational result of this stream processing pipeline that you define in SQL. Materialize is Postgres wire compatible, and I think in the future everything that even looks like a database will be Postgres wire compatible. This seems like a growing trend. More and more I see things either announcing Postgres compatibility, Postgres wire compatibility, or announcing the plan to add Postgres wire compatibility. If we could avoid Postgres CLI command compatibility, that would personally be okay with me, but otherwise this seems like a pretty solid standard. And Materialize also, as you could tell with this data warehouse language, positions itself as an analytics solution. Okay, I think you could use it to solve the transactional problem. There's nothing that I see in it that would prevent you from doing that. I have a stream, I want to just turn it into a table kind of thing. But it's, again, oriented towards the analytics solution. Okay, Delta Stream. Delta Stream is a company that happens to be founded by one of the original creators of KSQL at Confluent. He left and kind of started a cloud-native version of that same thing. And that's, again, how it builds itself, as a completely cloud-only, cloud-native. If you didn't have to worry about, there's an open source thing you can run in Docker or download the binaries and deploy it yourself. Like, if you didn't have to do any of that, what could you optimize? The answer is a lot. So they've got some, as a fairly young company, some features that are fairly innovative, like a completely serverless tier, a way of just saying, hey, I've got a topic off here, here's some credentials, bring some stuff in, here's my SQL. I don't know anything about your nodes or your clusters or any of that, just give me stuff, right? Also, bring your own cloud, which is not super easy to implement, but that's basically you give them your Amazon credentials, and Delta Stream will go set up stuff in your cloud environment, and that just all gets billed to you, and then you use their control plane. So that's again, if you were going to be cloud native, you get to optimize for things like that. Kafka, Kinesis integration, just like what you'd expect. You have materialized views, which are queryable, and these things called streaming pipelines, which are a topic transformed into another topic, transformed into another topic. And it positions itself on both sides of the OLTP-OLAP divide. So streaming database to them means we want to solve the transactional problem, and of course streaming analytics means we want to solve the OLAP problem. All right, Rising Wave. This is, they describe themselves as a distributed SQL streaming database. Again, if they're kind of sounding familiar, there's a reason. They have a cloud product. There is an open source version. What's super interesting about Rising Wave is it's a clean room reimplementation of Flink. Let's take the Java thing and rewrite it in C++. Everybody does it. If there is a successful enough version of JVM data infrastructure, Hadoop will turn into MapR. Cassandra will turn into ScyllaDB. Flink will turn into Rising Wave. Kafka will turn into Red Panda. We can't stop ourselves from trying to address that tail latency sensitivity use case that these things do so well at. But Rising Wave adds persistent views. As we'll see in Flink in a minute, Flink is stateful. It lets you do all kinds of sophisticated stateful things, but it doesn't give you access to that state store. It's always stream in and stream out. That's why I put a question mark. We'll get to Flink in a minute, but the question mark is there because you can't really use Flink to query a stream. Well, Rising Wave says, no, you can. We'll let you run queries against this thing. And again, Postgres wire compatibility, because that is how we do. Okay, KSQLDB is a unique to Confluent thing, and it's one of these community licensed products where you can get the code, you can run it for free, you can do anything you want with it as long as that's not make a hosted version of it. So it's that family of licenses that says this is just like an open source license, except not you, Amazon. And it describes itself as a streaming database with this persistent table abstraction that functions perfectly on the transactional side of things and on the OLAP side of things. So you could use KSQLDB to just turn a stream into a table and query it by key, or do arbitrary, potentially sophisticated analytical pipelines resulting in some queryable table at the end of things, or resulting in the stream in, stream out thing. It just like Kafka Streams, it will do that. In fact, implementation spoiler, KSQLDB is a SQL layer on top of Kafka Streams. So it basically compiles SQL down into a Kafka Streams topology. It's got this interesting technology. The terminology is often confusing to people, but this idea of a push and a pull query. A push query is where you've got some streaming pipeline and you want your application to get events as they come through it. That could be, resulting in a table, but you can do a push query and have the server push results to you when things in that table change. Or you could do a pull query, that's say a point query on a particular key where you're just pulling one result. Push queries never stop running. You're always getting more results from them. Pull queries, you might get a result and have the query run to completion. Yeah, as I said, Kafka Streams, but in SQL. Now, about Flink and Flink SQL. Why is the squirrel in the cage? Flink has become an essential technology for stream processing. It's one of these things, and this will be an interesting history talk I'll probably write at some point, but I've been thinking about how these preference cascades occur where there's this kind of open debate in the community. Is it going to be, this option, this option, this option? You see in the streaming SQLs, there's things all over the place, right? Nobody knows what the standard's going to be, and then all of a sudden, whoop, it's this one. So there was a debate. Will it be Kafka Streams? Will it be KSQLDB? Will it be Flink? We don't know. And in what seemed like a rapid transition, the community said, nah, it's going to be Flink. And you saw a year and a half ago Confluent acquiring an important Flink firm called Immerok, which was a recognition of that transition happening, right? So you got to have Flink, and it's likely going to appear alongside in a lot of stacks some of the other solutions we're looking at. It definitely performs stateful processing like aggregations and joins, but that state, as I said a minute ago, is not presently available for querying. It's a critical technology, but it's not something you can use to query a stream. So why is the squirrel here? Because some of these other things may require some pre-processing, like say connect and a relational database. At the end, we'll look at the real-time analytics, real-time OLAP databases. they ingest from a topic. Well, what are the odds that you just have that topic lying around that's exactly the thing you want to turn into a table to query? I don't know. That would be nice. Probably there's a few different topics. There's some filtering you have to do, some enriching, some other weird logic of, when this field is this, you have to fill this one over here. When it's that value, you go, all the kind of stuff that data ingestion is. Flink often fills that role, and it's becoming the standard tool for doing that kind of stream processing. So I want to just remind you, when we think about a database query, a traditional database query, there's a few stages computationally that are going on inside the database, right? You submit a query to the database, it parses that query, makes sure it's syntactically valid, SQL, we'll just say, make sure it's semantically valid. Are the tables and columns you're referring to things that actually exist? Okay, it is good. We'll hand it over to the optimize and plan stage. Sometimes these are broken out as separate stages, but here what it's going to do is look at, okay, what are the tables that are being accessed? What indexes do we have available? And there will be more than one way to execute the query. You try this table first, do this filter, get this result set. Okay, now get this one and do this join, and now go try this join and this. There's going to be lots of different ways to do it. The optimizer will, come up with a bunch of those, score them by some cost function, and pick one. So now you've got a plan. It can hand that off to the execution engine. We'll actually go do file I/O. It'll read indexes. It'll scan tables or portions of tables. It will join, filter, sort, aggregate, maybe aggregate, sort, whatever the query requires, right? It goes and does all that stuff where all of these nice fundamental computer science abstractions actually take place, and there you go, you got results, and you're done. So that's a traditional database query with what we might call data at rest, data sitting in a database, the good old days of the monolith. This was a database query. Flink matters, I think, because of a pattern like this. The stream querying we're talking about starts with events in a topic. Okay, there's a Kafka topic, things are happening, and like I said, it would be really cool if you already had the topic that was exactly what you needed, and you just feed it into Connect and dump it into Postgres and query it, or ingest it into Pinot and run your OLAP queries in real time and everything's great. Probably not. You're probably going to have to do some stuff, right? And that's usually Flink. Typically, this is the emerging standard answer is you're going to do that stream processing with Flink. Flink is not queryable. All it can do is dump stuff out into a topic. It's topic in, processing, topic out. And that seems limiting and opinionated, also seems to be the thing most people do most of the time. Then, all right, I've got that topic that is in shape. It's the thing I need. That I can dump into a database of some kind and then do those much simpler queries against that database that are more likely to be, key value looking key lookups. So I'm taking the more interesting optimization, planning, and execution stuff that database could have done, and I'm shifting that left back in the stream processing flow into work that Flink might do. So it is not properly an answer to the question. It often shows up in the stack, and this is why. Cloud data warehouses, obviously. And I guess fun thing about Gen AI, I would just never have been able to come up with, had the budget for, show me a cloud data warehouse, but make it look like Caravaggio. It's kind of fun. All right. So what do we know about cloud data warehouses? Well, we got BigQuery, Redshift, Snowflake, Synapse. We know that they are blue. Oddly, the designers, I guess, talk to each other. Maybe they go out for drinks. They like blue, or one of them did blue, and they all followed suit. It's what? It's a lake. Yeah, well, they're data warehouses. I think they're a little different than data lakes, but But I'll give you that. Maybe it's evoking water. So anyway, these are the cloud-based heirs of old school Kimball, Inman data warehousing, the stuff that started late 80s, early 90s, that was running on relational databases, that later turned into the big data systems like Hadoop and Spark to some degree, but more like legacy data warehousing in that they are structured. Okay, the data you put into a cloud data warehouse, and this is part of the distinction I'm making between data lake and cloud data warehouse, is that the data is explicitly schema'd data in one of these. They have roots in batch data ingestion, and they have non-functional performance characteristics that seem like batch systems. That is, they might be quote-unquote fast, but they are not the sort of thing that you would put in the loop of a user interface. You would not have someone tap on a button or thing on an app and go ask BigQuery something and come back with an answer. That's not going to feel alive. They're for powering dashboards, and they work well for that. So they're good solutions for that. And they're increasingly also adapted to streaming inputs. But yeah, as I said, they're biased towards structured data and batch access. Good for those things. You got a lot of data, and you want to create a dashboard. How quickly does that dashboard really need to update? You know, does it need to be 100 milliseconds? That's a little obsessive. I think you should calm down. Is 10 seconds okay? Usually it is, and that's kind of how they work. All right, data lakes. Now, the distinction between cloud data warehouse and data lake, and this really is the proper heir of Hadoop, of HDFS, and those things is we take all of the things and we write them into the data lake. We don't, by design, we don't worry about the structure, the format, any kind of stuff like that. I mean, you don't want garbage data. You might do some cleaning, but you're not trying to get everything completely normalized. You're trying to get it there. And later, when you read, then you'll figure that stuff out. It's a schema on read. It's this part of my backpack. Okay, so in my backpack, I've got here for like the iPad and the laptop. This, I've got, let's see, a hoodie, like some heartburn medicine, some extra cables, sunglasses, very much data lake energy here. This is a schema on read situation. There's just a bunch of crap in there, and every time, it's like I do a full table scan when I'm looking for my clicker. It's not good. So, yeah, this started life as HDFS 15 years ago. It is now pretty much S3 or Cloud Blob Store of your choice, and that didn't make things any better. There was this vigorous debate 10, 15 years ago that we're going to do extract, load, transform instead of extract, transform, load, and that's going to be revolutionary. Why worry about schema? Figure it out later. Well, every time we say that, ends up being a lie. It's like in 2010 when various databases said, we don't need SQL. We're going to be no SQL databases. And they all sprouted SQL, except Mongo. Mongo never did. But if you read the Mongo docs about the query API, every single one is expressed in terms of the equivalent SQL query. So, certain things don't go away. Schema is one of those things. That is why you see the emergence of, and by the way, this is another one of those preference cascade things. We spent a few years of these kind of data lake schema layers. It's going to be Iceberg, it's going to be Hootie. There's another one whose name I can never remember. That's kind of a new upstart. There was the semi-proprietary Databricks Delta Lake thing. Which one's going to win, right? And very recently, in the last few months, it seems like, Iceberg. Iceberg's the one we want. That is a system for imposing schema on top of the supposedly doesn't really matter what the schema is, data lake, which connects to a really interesting, shameless plug, Confluent thing that is you can't actually use this yet, it's just an announcement, but Tableflow is this Confluent Cloud feature where you can connect a Kafka topic to an Iceberg table and just dump straight from the topic into these structured things in a data lake. So it's interesting how these things are connecting to one another and where the tentacles are going, and that tables and schema remain a very durable part of our lives. Some other characteristics of data lakes: you've got this radical decoupling of storage and compute. You got storage kind of everywhere in this blob store, all kinds of different formats maybe, and then you've got other systems that go read that blob store and do compute. So you get lots of flexibility, cost optimization, high latency. That's a thing. Structure relatively less important, but that situation is evolving. Structure is emerging as a more important thing even in data lakes. Historically, these don't do so well with streaming, but they are all doing better. And little evolutions like this table flow thing, I think, are an example of the notion that no schema is really going to come home to roost in the data lake, and we need a coherent account of how streaming and this static batch-oriented analytics solution are going to cooperate. And so, again, people are experimenting, trying to figure out what the terrain looks like. Finally, real-time analytics databases. This is a fairly specialized but very interesting part of the terrain. They are explicitly designed for high concurrency and low latency. That means, I'm going to say, user-facing. So, analytics, historically, back in the when days, you made a report in Crystal Reports, and you ran it, and you printed it out on a laser jet, and you gave it to somebody important. Now that's a dashboard. That's in a tab in a browser, right? But how many people are really going to view that dashboard? And how often does that thing need to update? Like I said, not much. If, on the other hand, you're taking that analytics data and packaging it as a feature, like, here is this topic full of all of my meal deliveries happening right now. Let me filter it to a certain geography and category of restaurant, and I got 6 restaurants, and there are 300 deliveries that have happened in the last hour. Let me see what the average delivery time is for that right now, which could be changing second by second if we're near a peak time, right? That's a real-time analytics problem. It's an analytic query, but it's going to a user interface. So these are designed for that stuff: high concurrency, low latency. They typically ingest from batch and streaming sources, but they don't make a lot of sense without streaming. Being in a streaming world, you want them to be integrated very tightly with your streaming source, and you want to see, typically, the one I'm thinking about is Apache Pinot. I've spent a couple of years working closely with that. This is kind of analytics, but shaped like real-time data, not shaped like a dashboard. The ways of populating a dashboard are well understood, and they're good solutions. But if you want to turn this stuff around and expose it in real time as a user interface, you need a differently engineered solution. Now, in closing, a few thoughts. In a sense, this is a bunch of raw data for you to do technology selection. This is a technology selection talk. And what matters when you're doing technology selection? As a reminder, sometimes you go with what you know. This is not a bad thing. It might be simple, but it's the thing that you know how to do. Maybe it's not optimal in every regard, but you have the skills, you can make it happen right now. That matters. You can improve it later. Okay, that's a good consideration. Sometimes performance really matters, and you need to take measurements because there are tight SLAs, and you need to make this work. Okay. Sometimes there's a community that you need to think about, right? Are there other people? Can we hire people who do this? Can we go get help? Are there tutorials? When I Google stack traces, is it tumbleweeds? You want help, so you need to look around. But fundamentally, where we are right now as a community in this space, and in my view, just about anything related to streaming, there are 3 important things. Kafka has, to a large extent, succeeded as the new data substrate. We're building systems on top of it. It's where a lot of data goes. Now, this does not mean databases go away. As I hope I've made clear, they're still absolutely essential. At the top, you've got the code you're actually supposed to write that does something useful for the people you serve, your company's customers, whatever that is. That's really where, if you're an application developer, that's where you should live. That's what you actually contribute. But in the middle, there's all of this infrastructure that I just described a bunch of pieces of Some of those are not going to be around in a few years. Some of them might decline. Some of them might increase. We're finding that out. We're exploring that middle area. And there's this temptation when things are not known, as they are right now, for us to come down from the application and go build little pieces of infrastructure. You got to watch out for that. That is, as Admiral Akbar would say, a trap. You don't want to find yourself down there building infrastructure if you don't have to. It's not really what you get paid to do as an application developer. But because we're in this time of there being all this uncertainty, it can be difficult. You are exploring unknown terrain. That is what we're doing right now. Happened in the 80s when client-server happened. That's a historical footnote now. You are now writing the stuff that people, writing the history, living out the history that people who are right now learning how to eat, will be benefiting from in 25 years when they're writing software. Finally, if anyone noticed, Caravaggio, we're just at time, give me just a minute, did in fact paint women. I noticed as I was getting these from GPT-4, they're all men. I'm like, you had the penitent Magdalene, you had Judith beheading Holofernes, you had Death of the Virgin, Salome with the head of John the Baptist, did definitely paint women. Finally, when I asked for this picture of a bunch of people, ChatGPT was willing to put women in the picture. I don't know if anybody noticed. But there you go. If you want to know more about the streaming side of stuff from a Confluent viewpoint, that is my website, Confluent Developer. That's me on LinkedIn. Follow me if you like. Thank you for being here. Have a great day.